Hi, welcome to another video by emilylearning.com. So in this video, I'll be sharing with you what is tested in the topic on magnets for O-level physics. So let's get started. The best way to find out what is being tested is by looking at the syllabus. So now let's take a look at the syllabus.
So here we are at this section of the syllabus. Okay, so for this chapter, it is on magnetism. So what would you need to know for this chapter? Well, firstly, you need to be able to state the properties of magnets. So basically, what are the properties of magnets? Well, so magnets are able to attract magnetic materials. So they attract magnetic materials. And what are magnetic materials? Okay, well, basically for your syllabus, you need to know that steel and iron are examples of magnetic materials. Cobalt and nickels are also some other examples of magnetic material, but for the purpose of your syllabus, you need to remember steel and iron. So a magnet is able to attract anything that is made of steel and iron. When you have two magnets, okay, a magnet will have a north pole as well as a south pole. Okay, so if I were to suspend a magnet freely, okay, so it will spin and finally come to rest, okay, with the north pointing to the north position of the earth. All right. Next, when I have two or more magnets, and I place them close to each other, then what will happen is that like poles will repel each other. So for instance, if I put a a south pole facing a south pole, so south and south are like poles, right? They're the same pole. So they will repel each other or they will move away from each other. Conversely, unlike poles attract. So what this means is that if I were to have unlike pole, that means a different pole facing each other, so north and south when they face each other, then these two magnets will move towards each other as unlike poles are attracted towards each other. All right? All right, so that are some of the properties of magnets. Now, let me erase everything and here you are. Okay, now what I want to talk about is induced magnetism. Okay, so to do that, let me draw another diagram here. Okay. So when we are talking about magnets, like poles will repel and unlike poles will attract. Okay, but if we were to pick a magnet towards a magnetic material, like for example an iron nail, it doesn't matter whether it is the north pole or the south pole. Okay, the iron nail will be attracted towards the magnet. Okay, so when you have a magnetic material versus a magnet, it will always be attraction. Okay, and this attraction is what we call induced magnetism. So what this magnet does, so maybe let me draw another example. So now I have a north pole and a south pole here. So this iron nail by itself, it has a lot of magnetic moments inside it, which are not aligned. So when placed close to a magnet, it will cause the small little magnetic moments to become aligned. Okay, and when that happens, the iron nail will have induced magnetism. So when a magnetic material is placed close to a magnet, the side of it closer to the magnet will have the opposite pole being induced in it. So therefore, when the iron nail is placed close to this magnet here, a south pole is being induced at the side of the nail closer to the magnet, and a north pole is being induced at the side further away from the magnet. Okay, due to this induced magnetism in the iron nail, attraction takes place, okay, because these are unlike poles. Okay, so this is what you need to know about induced magnetism. Okay, next in part C, you are asked to be able to describe electrical methods of magnetism and demagnetism. So if you want to magnetize something permanently, you will place it into a DC circuit, all right? So I'll connect it to a DC circuit. So maybe I'll have a resistor to control the power, and I close the switch. So when I connect, so this coil here is what we call solenoid. Okay, so I'll place a steel bar, which is a magnetic material, into the solenoid, and I switch on the power, or I turn on the switch. So current will pass through this soft iron, will pass through the solenoid as well as through this, and so the steel bar gets magnetized. So in short, to magnetize a magnet or a magnetic material, what you need to do is to place the magnetic material into a solenoid connected to a DC supply. Okay, and it will become magnetized. To demagnetize a magnet, what you need to do is to use a AC current and alternating current. Okay, so what you need to do is to place a magnet into an AC supply. Okay. And so once you place the magnet into this AC supply, you need to slowly remove this magnet from the solenoid to demagnetize it. Okay, so so remember this diagram here is to magnetize. This diagram here is to magnetize a magnetic material. Okay, you use a DC supply. Okay, then place the magnetic material in the solenoid. If you want to demagnetize a magnet, what you do is to place the magnet into a solenoid connected to an AC supply and slowly remove the magnet from the solenoid. Okay. For D, you need to be able to draw the magnetic field patterns around a bar magnet and between the poles of two bar magnets. Right?
So in terms of magnetic field lines, this is what you need to be able to draw. So if you are given a single magnet, you need to be able to draw the magnetic field lines for that single magnet. So remember, when you are drawing the arrows always point away from north towards south. Okay, and also closer to the magnet, the magnetic strength is stronger, so your line should be closer together. Further away from the magnet, the line should be further apart. Okay, so if you are given two magnets, then you need to be able to draw them when they are being repelled from one another, like in this scenario here, or when they are being attracted to each other. All right. To draw
Okay,
the
in part
magnetic field
E,
lines between
you
two
need to be
magnets
able
that
to
are
describe the
attracted to each
plotting of
other. So
magnetic
remember,
field
here
lines
is
with a
south, here
compass.
is
What this
north. They
means
are
is
unlike
that, for
poles, so they
example, if
attract.
I have a
So what you
magnet
need to
here,
do first, draw one line.
so
Okay, it
north,
should be a
south.
straight line, all
If
right.
I want to
Okay, then
plot
draw
the magnetic field
this
lines, what I can do
here,
is I can
another
place a
one
compass
here.
here and wait
Okay, it
for
should be
it to
symmetrical.
come to rest.
Okay.
And what I'll do is,
Okay,
for
then you have
instance,
something
this is
here.
where the north is pointing. So I place a cross here. Okay, then I will remove this compass. Okay, and I will place it here, and I will align it until the bottom position is on the cross here. So for example, this here. Then alright, next you need to be able to describe the plotting of magnetic field lines with a compass. Okay, seldom do you have a question asking you how you can plot a magnetic field lines with a compass. More often, this comes out as an MCQ question. So let me give you an example of how this part E is being tested. So you have this compass here. Okay, so they say that X is a compass, all right? And they ask you which one shows a correct way in which the compass is pointing. So you have maybe option A being this way, option B being this way, option C being this way, and option D being this way. Okay, so to do so, right, what you could do is by drawing the magnetic field line through the compass. So let me change the color. I'll use red to do so. So for instance, I want to draw a magnetic field line from the north to south pole. Okay, I know that the magnetic field lines here will look like this, and the arrow should be pointing away from north towards south. Okay, so at the compass area, I know that the magnetic field lines look like this. So this should be how the compass looks like. So your answer would be option B. Okay. Lastly, let's look at part F, where you are asked to distinguish between the properties and uses of temporary and permanent magnet. So temporary magnet, for your syllabus, you need to know that iron is usually used to make temporary magnets, and permanent magnets are usually made of steel. So for temporary magnet like iron, they are made of soft iron material, and these materials are easily magnetized and demagnetized. For permanent magnets, they are not easily magnetized, but once they are magnetized, they retain their magnetism for a longer period of time. So iron is usually used for application where you need temporary magnets, and for permanent magnets, you will use steel. Okay, so if I want to make a bar magnet, okay, if I want to use a bar magnet, I will definitely use steel because I need this to be a permanent magnet all the time. It will still be a magnet, okay, no matter what. But for some applications like the electric doorbell and so on, we need a temporary magnet. Okay, then so what we'll do is we will place this iron bar into a solenoid. Okay, connected to either an AC or a DC supply. Both are okay if you want to make a temporary magnet. Okay, so when the switch is open, this is not a magnet, and when the switch is closed, electricity current flows through this solenoid, and this iron piece becomes magnetized. Okay, so this is you use iron for temporary magnets. Okay, so now that I've covered what is tested in this chapter on magnetism, right, you'll notice that a lot of it is application. So you need to know these properties, you need to know about induced magnetism, describe electrical methods of magnetization and demagnetization. This one can come out as a regurgitation question. C. Part D can also come out as a regurgitation question where you need to draw the magnetic field patterns around a bare magnet or between the poles of two bar magnets. But the rest, A, B, E, F, it is all application. They give you a scenario and ask you questions based on this theory that you have learned. Okay?
Thank you for watching this video. Do subscribe to keep updated with our latest videos. And if you are interested, we do have an entire playlist on all the topics tested in physics O level where we share with you what is tested in detail. Okay, in addition, if you want to learn in detail, do check out our courses on Udemy. Bye and see you.